All right, let's talk about one of the biggest shifts happening in technology right now. We're going to dig into how artificial intelligence is moving beyond just a big general idea and becoming this incredible set of specialized tools. Tools that are completely rewiring entire industries, from healthcare all the way to national security.
Okay, so let's get right into it. The core idea for today is what the source material calls the specialized horizon. Now, this is really important. You've got to stop thinking about AI as just one single thing. This is all about taking those general AI skills, understanding language, recognizing images, and engineering them into hyper-specific, mission-critical solutions that can tackle jobs at a level we could have only dreamed of a few years back. So here's our game plan for this explainer. We're going to start with the basic building blocks of AI. Then we'll dive into a couple of really high-stakes examples, healthcare and cybersecurity. After that, we'll zoom back out to look at the challenges that everybody is facing. And we'll wrap up by asking the big question, what does all of this mean for the future of intelligence itself?
To really get a handle on this specialized horizon, you have to stop seeing AI as some kind of single magic box. A much better way to think about it is as a stack of capabilities, kind of like a toolkit, where each layer builds on the one underneath it to create something seriously powerful.
This slide really lays out that toolkit perfectly. It all starts at the bottom, layer 1, with basic perception, just taking in all the world's messy data and making sense of it. Then layer 2 comes in to automate the logical stuff. But the real magic starts happening in layers 3 and 4. This is where AI actually begins to reason, to predict what's next, and even to self-optimize. And that's the giant leap from just doing tasks to actually driving strategic decisions. So let's see how this stack actually gets put to work in the real world. We'll kick things off with our first deep dive, the super high-stakes, highly regulated world of healthcare. This is a place where the incredible promise and the very real peril of AI are crystal clear.
On the one hand, you get this absolutely mind-blowing precision. In medical diagnostics, for instance, AI models can hit an accuracy score of 0.94 when they're detecting cancer from images. Now, to put that into perspective for you, that is expert-level performance. That's on par with a highly trained, experienced radiologist. The potential here to save lives is just enormous.
But, and this is a huge but, here's the other side of the coin. The source material points out that those same super accurate systems often get terrible scores. We're talking like a 4 out of 10, when they're reviewed for things like data bias and integrity. This shows a massive, massive gap between what an AI can technically do in a perfect lab setting and what's actually safe to use in a real hospital with real patients.
And that right there, that perfectly illustrates the central tension we're seeing today. The problem isn't the raw power of the model. It's the black box. I mean, if a doctor can't understand why an AI is recommending a certain treatment, how on earth can they trust it with someone's life? It's this lack of explainability, of governance, that's the real roadblock to getting this amazing tech into hospitals.
Okay, now let's switch gears to a completely different world where the rules are basically flipped. We're talking about cybersecurity. Here, it's not about slow, cautious trust. It's all about speed and constant adaptation.
And here we see the ultimate double-edged sword. The very same AI that helps us build our defenses, finding security bugs, automatically writing patches, is being used by the other side to create smarter, more adaptive malware and to automatically find ways to break into our systems. It's literally the same tech being pointed in opposite directions. This quote from the source material just nails the new reality. We are moving past the era of humans defending against human attackers. It's quickly becoming a full-blown algorithmic arms race, a battle of AI versus AI, happening at a speed and scale that no human team can possibly keep up with. So after looking at those two totally different fields, let's zoom back out. Because whether you're working in a hospital or security operations center, it turns out there's a set of universal challenges that cut across every single industry trying to use these powerful new AI tools. These 4 issues are really the heart of the matter. You've got data bias, where a model trained on a flawed picture of the world will just make flawed predictions. Then there's that black box explainability issue we saw in healthcare. You have the dual use problem from cybersecurity. And then there's what the source calls the autonomy paradox, which is this weird situation where the more independent and capable we make our systems, the harder they actually become to supervise and hold accountable. Nailing these challenges is the key to building AI we can really rely on. And all of this work, right, all of these specialized tools, all this progress, it naturally leads us to the ultimate question. Where is this all heading? Is this whole specialized approach the path that's eventually going to lead us to true artificial general intelligence, or AGI?
Well, here's a key insight. For all their power, today's AI systems are fundamentally brittle. They're absolute masters at spotting patterns based on data they've already seen. But the moment you throw them into a truly new, dynamic situation they haven't been trained for, they often just break. Their intelligence doesn't generalize the way humans can.
So, to get past that brittleness, many researchers think we need a whole new foundation. And this is where fascinating concepts like neuromorphic computing come into play. It's a type of computer architecture that's literally inspired by the human brain, one that doesn't just train once and then stop. It learns continuously, adapting to its environment in real time. This might just be the architectural leap we need to get to truly general intelligence.
Which leaves us right here with this final, really provocative thought. As we push to build AI that's more powerful, more adaptive, and more autonomous, we have to ask ourselves, are we just solving today's problems of bias and brittleness? Or are we on the verge of creating an entirely new class of risks so novel that we can't even begin to predict what they are yet?